Hi everyone, this video is going to be about complex numbers. It is section 1.5 of our textbook. This video is going to be relatively short. I like to do section 1.5 before I do section 1.4, and you'll see why when you watch 1.4. 1.5 is about a complex number. In mathematics, we like to make things complete. So when we came across the square root of a negative, we didn't like that. We were like, we need to do something with that. We want to be able to work with that. So what we called it was an I. Being imaginary, it's some sort of imaginary piece of, some imaginary number. Like I said, mathematicians made this up. It is all kind of just defined that way, so you can't really argue with definitions. So I represents or is defined to be the square root of -1, or the square root of -1 is defined to be I. And we will talk about complex numbers more in detail later at the end of this course. So keep that in mind. We're going to dive into these complex numbers a little bit more in depth, kind of introduce you to the field of complex numbers. There is a whole area of mathematics designed to talk about how complex numbers work. Well, if I is that square root of -1, that means that I squared is, squaring both sides, just -1. We're going to need that fact when we start using these numbers. So a complex number is of the form a plus bi. We like to think of this as a real part. A is considered the real part, and B is the complex part or imaginary part. And together they create a complex number. So this is considered a complex number because it consists of a real and an imaginary piece. Now, I do want to mention that all real numbers are considered to be complex numbers because real numbers, the b is 0. So the number 7 is considered a complex number. So the real numbers is a smaller part of the complex numbers. So we're just kind of building. Remember, we started with natural numbers, counting numbers, 1, 2, 3. We added 0. Then we started adding negatives, or maybe we added fractions first, probably. Fractions. Then we added negatives because we started dealing with money. And then we started thinking about there's got to be numbers in between our fractions. So that's where those irrational numbers came from. So anyway, let's consider two complex numbers. So we have 4 plus 5i, 3 minus 2i. And we're going to talk about how we add them, subtract them, multiply, and divide. I like to think of it so here's one, and we're going to add the other. Think of I almost as a variable. It does have a definite value to it, but we can think of it as a variable. And then when we're adding, we simply want to combine our like pieces. So we're going to be combining this 4 and that 3, and combining the imaginary parts, and we'll come up with 7 plus 3i. So again, very similar to dealing with expressions in terms of having a variable there. So if I had these two numbers and we were going to subtract, the first thing I would do is distribute that negative through, and then combine my like numbers or combine my like pieces, and I would end up with 1 plus 7i. Okay, we cannot combine our real parts with our complex parts or our imaginary parts, so we kind of have to work with those. Multiplying, we are going to use FOIL. So we'll have that our firsts, the outers, our inners, and our lasts. We are going to combine our like terms, so 12, this becomes a 7. And then we're going to remember that I squared is -1. So I'm going to take that I squared, turn it into the -1. I'll have a -10 times that -1. And I'm writing all the little steps out here for us. And then combining my like terms again. 22 plus 7i. We do like to write the real part first. I'm not real sure why. Well, yeah, I do understand why, but we'll talk about that more when we get further on down the semester, towards the end of the semester, actually. All right, we've added, we've subtracted, we've multiplied, so of course, the last thing we have to learn how to do is divide. Okay, and this is where we have to remember that this represents a square root. So think of this as like 3 minus 2 square root of something. And when we divided things with square roots, we wanted to rationalize that denominator, so we multiplied by what we called the conjugate. So we will do that here as well. So we're going to multiply by that conjugate. And again, we will actually distribute everything, multiply everything out. Okay, so I'm going to do that 12. We'll have plus 8i plus 15i plus 10i squared on the top. On our bottom, we'll have that 9. We'll have a plus 6i minus 6i and then minus 4i squared. I'm going to do a couple of things here. I'm going to remind myself that I squared is -1. Okay, which turns this into a -10, which turns this into a +4. And I'll also combine my like pieces. So in the numerator, we'll have that 12, and then this -10, which gives me a 2, and then we'll have that plus 23i. In the denominator, notice the 6i and the -6i cancel. This becomes a +4, so we'll have 13. We can write this in that a plus bi form as 2 over 13 plus 23 over 13i. Notice we can have really ugly a and b. They're just real numbers, and sometimes real numbers are not pretty. Yes, we can even have square roots if we wanted to, like the square root of 3 plus the square root of 7i. A lot of times in those cases we'll write the I before that square root, so it doesn't seem like the I is slipping underneath that root symbol. So there is a real quick overview of your complex numbers, how to add them, subtract them, multiply, and divide.